Hello again, Year 9. Here is your third week of electricity at home. This week is all about appliances and efficiency. You've got a do now on the first slide, which has got 3 equations for you to decide, are they correct? Do they need to be changed? You've also got a little reminder at the top that you are going to need a calculator to do this work. If you have not got a calculator with you at home, and you are using a laptop or a tablet, where the little Windows button is at the bottom left hand corner, if you click on that, it will give you an option to open up a calculator under the letter C in the drop down alphabetical menu. That may help. Okay, pause the slide while you answer these questions now. Okay, that was a bit of a meanie because all of those were correct. I want to give you the confidence that if you've written something down, you're sure it's right, to go with it rather than to doubt yourselves. Moving on to today's objectives, there are only 4. First of all, understand what efficiency is in the context of appliances. You need to be able to calculate and compare efficiency for different appliances. You've got to practice various calculations, and you are also going to do an audit of appliances in your home. So here we go. First of all, sad story from lockdown. It's sad but true. During the first week of lockdown, when all the shops were shut, my washing machine broke down. My laundry basket quickly started to overflow. How should I choose a replacement? It would obviously have to be online. Now going to look at the machines and touch them or whatever in the shop because everything was shut. And although washing machines I think are fairly essential, those shops were shut too. So, drew up a list of criteria. Colour. Did I want a white machine, a black machine, a silver machine? I think there are a few others, but they tend to get rather expensive. Capacity. That's how much you can fill in the drum. Spin speed. Price. Warranty. That's how long the guarantee will last under which they'll repair it. Or energy efficiency. You've got A double plus, A triple plus. It's got a bit confusing. Now, most of these are quite straightforward, colour, capacity and what have you, but what is efficiency? I needed to find out, and so will you during this journey with me. So, you go shopping in one of these places now that they are reopened. You will see stickers like this on every appliance. You will also see these on the side of the sleeves in which light bulbs come, so that's probably an easy place to find them in your home. You'll also see a similar thing if you go onto a home sales or rentals website such as Zoopla or Rightmove, and these are energy efficient ratings. Like so many things in the world, they go up a little rainbow, or there's no purple this time. You've got red at the bottom, letter G, not very efficient, all the way up to 90 to 100% efficient at the top. And obviously the higher up you get, and the earlier the letter is in the alphabet, the more efficient it is. When it comes to a house rental or property purchase, you have a current level and a potential if you make some changes. If you're buying an appliance such as a washing machine or a light bulb, obviously the efficiency is the efficiency. It's not a good idea to tamper with it at home to try and make it more efficient for fairly obvious safety reasons. So how is energy efficiency decided? Now we already know a couple of equations we might need. We know that energy transferred is power times time. Please remember, time needs to be in seconds. That is the area that most errors occurred in the calculations we had last week, forgetting to change it to seconds. And power itself is current in amps multiplied by potential difference in volts. So if you have a 1 kilowatt heater and you use it for 1 hour, that would use the same amount of energy as a 2 kilowatt heater for half an hour. But efficiency is the measure of how much of the energy that goes into the appliance is used in a useful manner. So we know, for example, if you're changing a light bulb, you may, or you've watched your parents change a light bulb, you may well have seen that they put a tea towel around their hand when they take out a light bulb that has blown, is no longer working, because as well as producing light, sorry, typo there, they can also become hot. The transfer to the thermal store is wasted energy because we don't actually want to use a light bulb to heat something, we want to use it to brighten up the room. So you have useful energy and wasted energy. And the efficiency, moving on now, is the output power divided by the input power. If you want to make it a percentage, you multiply it by 100. Now, important note, if you're doing the basic number output divided by input, efficiency will always be below 1. If it's a percentage, it will be below 100. You cannot have anything be more than 100% efficient because that means it will be putting out more power than it's taking in. And the law of conservation of energy tells us that that is not possible because energy is not made or created, just transferred. Now, there may be energy wasted through heating, there may be energy wasted through friction if you've got moving parts in a machine. There's the two main ways of wasting it. Here's a sample calculation. I'm going to give you the question first, then I'm going to do it in sections for you. If you want to write it down, make your own copy, you can pause the video as each slide goes through. I'm just doing it in little steps for you as a model. So, calculation. A 230 volt 12 amp motor has an efficiency of 60%. Calculate the electrical power supplied to it, calculate the output power of the motor, calculate the energy per second that is wasted by the motor. We'll do each of these sections separately. So, section 1, we know we've got volts, we know we've got amps. I've circled them in different colours. Now, our equation that has amps and volts is power. So we can work out the power first of all. So power is 230 multiplied by 12, which is 2,760 watts. So that is the total power going in. Quite straightforward. You can do it in your head if you haven't got a calculator by splitting the 12 into 10 and 2. So you could do 10 lots of 230 is 2,300, and then you can double it as well for another 460. Add it together. The second part, now we've got the efficiency, is output divided by input. However, in this case, we know the efficiency and we know the input. We want to find the output. So we're going to rearrange it so that output power will equal efficiency multiplied by input. So as this was divided by input, you multiply it to move it onto this side here and make output the subject of the equation. We don't call it rearranging. If you're in maths, you talk about changing the subject of the equation. 60% make it into a decimal, easy to work with, 0.6, because it's not asking for a percentage. So 0.6 times 2760 equals 1660. That is what is coming out. That is the useful energy. Moving along now to the third section. You need to look at the energy wasted. So first of all, you know that the input was 2,760. You know that the output is 1,660. Take the smaller number away from the bigger number. Always smaller away from bigger. It wouldn't be the other way around because we would not, otherwise we would be making energy. That's a very simple, quick check for your maths. Always subtract the smaller number from the bigger number in these sort of calculations. Here comes some practice for you now. So you have got 4 different types of light bulbs here. You've got a filament lamp, that's the traditional one. You'll have seen with this bit that looks a little bit like a spring inside, a halogen bulb, low energy compact fluorescent bulb, CFL for short, compact fluorescent lamp bulb, and light emitting diode, LED. Each of these have got a power in watts, each of these have got an efficiency. So first question is, how much energy is wasted per second by the filament bulb lamp compared to the CFL? So you're going to have to look at both of those and work out how much energy is wasted. Not how much energy is used, how much is wasted. So here, if you've got 20% efficiency, you'll have 80% wastage. There's a little hint to start you off. Second question, The student claims if you have 50 LEDs, that gives the same output as the halogen bulb. This is incorrect. Explain why, and calculate how many LEDs would actually be needed to have the same efficiency. Now, I'm sure I'm not going to have to remind you that rather than just sending me a number, you will need to have your whole calculation showing. 2 reasons. First of all, it helps me and it helps you to check your work. Secondly, if you make a mistake, and this is a multi-part question, this part is probably worth 2 or 3 marks, you would get marks for the bits you got right if you show the steps. You don't show the steps, you can't get any marks, so we're getting into our good habits ahead of our GCSEs now. When you've paused that page, done the work, you can move on to the next questions. I'm going to tell you very kindly that I have also provided a sheet of mixed calculations for you to practice. You must do at least 5 of the questions, including the last one. How many you do is up to you. If you do all 5 and you feel confident, send them to me. If I'm happy they're all right, we'll both be happy you're confident, and that'll be great. If you send all 5 to me and none of them are right, we're going to do a bit more practice. I'm just showing you a little snip here from the sheet. So the questions look like this, but there's also, I'm going to provide you with an answer help sheet where you've got 1, 2, 3, 4 steps for each, and you can put it in the boxes. If you don't have paper, you can download the sheet. You can put a text box each side into each box here. So insert text box, make the text box that side, type what you need to do, then go on to the next one, new text box, and that way you can type over it. It should be quite straightforward. This will also help you show all the steps in your calculations. Very good practice for you, Year 9. And finally, how energy efficient is your home? I want you to have a look to see what type of light bulbs you've got. Hopefully you've got some spare light bulbs in the cupboards. You will have those little rainbow diagrams to show you how efficient they are. You can get an idea how many energy efficient light bulbs have you got in your house. If you've got some new appliances in your house, they may have stickers on them. Or you can have a look at your appliance, find out what type it is, look on Currys or AO.com to see how efficient they are. See what is good in your house, see what could be changed, perhaps have a conversation with your parents. Although efficient appliances are more expensive and replacing appliances is expensive, they will save you money in running costs. I know from a personal point of view that at one point I had a really big chest upright freezer that I inherited from a relative that passed, and it did a very good job at keeping the food frozen. However, it did break down one day, which is not surprising because it was 35 years old at that point. And when I replaced it with a modern, smaller one, I found that my electricity bills actually dropped by over £10 a month. So it didn't take long for it to pay for itself. Now, we are getting really good at doing these quizzes, so I found us another one. Yay, I hear the cheers now. And as well as submitting your quiz score, you remember you need to send at least 5 of your calculations. If you did them in the sheet, you can just send the sheet over. You can submit your work via Teams or via email, but please make sure you remember to do it. Any questions, any problems, you know how to reach me. Take care and hopefully see some of you very soon, Year 9. Bye for now.